Hello guys, I hope you're all fine. And in the last week, I introduced the Pro-II Process Engineering Aveva software and show you a simple demonstration of the software through an example and showed you that what steps you should follow to complete your simulation into the main flow sheet. Now in this video, I'm going to show you how you can use the heating curves present in the utilities area of this template. I've already added the stream with the required petroleum assay distillation and the process conditions of temperature and pressure. You can see that I've already entered the flow rates. You can change it, and you can also change the unit of measurements as you like this, which I have already explained in the last video. So coming to this, that in the stream data you have 4 options, like if you want to put the TPP distillation into the sheet, or the D86, D1160 and ASTM D2887. So what's the difference between these 4 distillations? So TPP distillation is the most accurate distillation, and because during the testing or the laboratory distillation, the conditions are maintained with 5:1 reflex, and the results are more accurate than other distillations. But this TPP is time consuming and is expensive. So coming to the D86, which is easy and less time is required to perform it, but in this distillation there are no reflexes set, and all the crude sample vaporized is directly goes to the condenser with no reflex. So the accuracy is lesser than the TPP, but daily testing of the products can be done with the D86 because with some errors if I talk about the errors, then TPP data is 5% more accurate than D86. So coming to the ASTM D1160, is mostly used for the vacuum testing, pressure below 1 bar atmospheric. So this is utilized, this method is used, and these are all the STM methods. And D2887 uses the gas chromatography for the fractional distillation of petroleum products. So you have so many options here. Either if you have the gravity curve with the percent distilled, then you can also add this for the accuracy of the feed data, molecular weight versus distillation curve, and the light ends. So these are the additional data which you are entering here. So if you do not have, then there is no problem. You just enter that distillation here and just click the okay. So as you see that I entered this 375 degree F temperature and pressure 300 psi. So let's enter the heating curve here. So it is present in the utility section of the template, from where you just click it and drag it into the main flow sheet. When you click it, you will see that there is a small graph is showing into the sheet. Double click it. Now you need to enter our data here. We have a steam to be evaluated, which is 1 steam, and now we need to enter data here. So we need to check in the first specification we are required. So I'm taking this equal enthalpy increments. Now I have to give it the second specification, which is which should be the temperature and pressure ranges. So I know that after the preheat exchangers, normally the temperature is around 190 degrees centigrade. So in the Fahrenheit, I'm giving it as 375, and I'm increasing the temperature. Ending temperature is 690 degree F, around 360 degrees centigrade, and the pressure is the starting is 300, and the after passing through the furnaces, the transmission line pressure is normally in the range of around 50 psi. So that's the data which we need to run the setting curves. So just click the OK, and you see that there is a round blue color block is showing. It means that we have already entered the data. So just click again OK. Now we will run this, and this is the flow sheet status. Let's close it, and next tab is the spreadsheet. And now our objective is to move this sheet into the more explanatory heating curves, and for that we have the heating curves function into the spreadsheet tab. Just click it, and it now starts working. Macros are added into the sheet, so we need to put enable macros into the dialog block and wait for some time here. If you have a good PC, then it will take less time. It's working. Now this load heating curve data in Excel dialog block is open now, and what we need to do is to just click the HC1, then click add, then again click the stream 1, add. Here is the option that in which unit you want to display your results. So I'm going with the output units, then click the OK button, and now you can see that it's generating the Excel sheet with the macros, and there's a readme tab to see that how we can greatly use this sheet. So you can see here that we have the curves, and with the properties and the trends available to see the behavior of the crude with respect to temperature and pressure changes. So what further we can do things. Okay, so here we have option that if we want to further adding some stream properties into the Excel sheet, then there is options like report molecular weight, report entropy, enthalpy, transport properties, critical properties, this and that. So I click all these, and this one to click OK. Okay, now again I close it again, don't save. Now I will generate again the Excel sheet and see that the molecular weights are there and other properties or not. So just click again the rating curves. It will again take some time to open the main flow sheet with the macros. So this time it is taking a lesser. So here is the summary of the rating curve. So we have the viscosity curves, thermal conductivity, CPs, Watson K, critical temperatures and pressures, and this highlight is showing that at this temperature and pressure we have the 100% liquid, and after that um, vapor phase is appearing into the stream. So now if we want to analyze the graphical representation of this data, so we need to drag it down the Excel sheet. You see that there are automatically generated graphs here, so you can take the idea of the crude properties and analyze with respect to your system configuration that it is reliable or not. So this is the small demonstration of how you can add the rating curves into the Pro-II Process Engineering software. So do not forget to subscribe the channel and stay tuned. We will have more material for you. Thank you very much.